Okay, so we're going to look at number 2 from the review now. And we're looking at where this function's not differentiable. So we have this graph, this function below. We want to know where it's not differentiable. So let's see what we got here. So in general, let me give you some reminder descriptions here. A function is not differentiable where there's a cusp or a corner. So for example, right here, right, there is a cusp. So at x equals, what is that? It looks like -7. So at x equals -7, it's not differentiable because there is a cusp. And the reason being, so if you're like, well, why is that? Why is it not differentiable there? The reason being that it's not differentiable is, remember what we're doing is we're taking a limit from the left and the right. We're taking this limit as we're approaching this point. So imagine this point. I'm going to zoom this in here. So imagine this point right here, okay? And think about what's happening. We're looking at these slopes. As I approach it, I approach from the left and I approach from the right. Notice what happens. As I approach from the left, I've got all these positive slopes, right? So if I were to say, what is a tangent line at the purple one, I'd say, oh, it looks like, as I approach from the left, it looks like it's something positive. But as I approach from the right, all those slopes, as I approach from the right-hand side now, all those slopes are negative. So I'd say, well, as I'm approaching from the right, they're negative. So in other words, I'd have positive slopes from the left, negative slopes to those right. Those numbers, whatever those numbers are going to be, they're not going to be the same. So my conclusion would be, at x equals -7, it's not differentiable. So again, the big reason, so that's why it's not differentiable, but we can identify that easily instead of kind of going through that huge description by just saying, oh, there's a cusp there, it's not differentiable. Now, let's look at another one. At x equals, I want to do this in purple. At x equals -5, it's not differentiable. Why? Because we know that differentiable functions have to be continuous. And it's not continuous there, so it's not continuous at x equals -5, right? Because there's a hole. Therefore, it's not differentiable either. Same thing at x equals -2, right? X equals -2, not differentiable. Why? Because it's not continuous there. As we move on to x equals +2, right? We have a corner. So at x equals 2, not differentiable because of a corner. And then finally at x equals 6, right? Not differentiable because, again, it's not continuous at x equals 6. Okay, so those are our values where it's not differentiable. Okay, let's move on to some basic differentiation. Let's see how far we go here. So we're going to take the derivative of this first one. Hopefully that's going to be easy enough. This is just following the rules. Going to apply power rule here. Actually, let's zoom out a little bit there. So we get 8x to the 7th. We're good to go. Let's go on to b. So again, reminder with b, what I'm going to do is I'm going to rewrite this algebraically. So I get 6x to the 1/2 plus x to the 1/3. That's some algebra. Now time to take a derivative. So I say h prime of x equals 1/2 times 6, which is 3, x to the -1/2. Let's make that -1/2 look a little neater. How about that? So -1/2 plus, okay, taking the derivative of that, we get 1/3 x to the -2/3. Okay, let's keep on going. Let's see. I don't know how far I'm going to go here. Let's see. Let's do a few more, though. Let's do letter C. Letter C. So again, I'm going to do this algebraically first. So I've got I could do quotient rule, but I could also algebraically write this like this. And now I can apply an easy power rule, right? So why not do that? So g prime of t equals -4/3 t to the -3. Let's continue. Let's do letter D. So actually D looks pretty good. So I'm going to say f prime of theta equals, well, taking the derivative of 2 theta, I get 2 minus 3 times the derivative of sine theta, which is cosine theta. Okay? Let's keep on going here. Let's do E. So E, there isn't a lot to, again, another one of those ones that's really not a lot to say here. So f prime of x equals 1/2 x to the -1/2 plus, right? It's going to be plus 1/2 x to the 3/2. Okay, let's see here. Let's do letter F. I feel like we're getting to that point where I'm going to need a little extra space here. So I am going to grab letter F here and do it on a different one because I don't think I'm going to have room. So let's do it here. Let's get rid of that. So let's do letter F. Oh, I don't think I'm going to be able to do it. Oh, good, I can. So let's do F here. So F, I have a product rule. So f prime of x equals, taking the derivative of the first function, I get 6x times the second function. Now it's going to be plus the derivative of the second function, which is 2x minus 2 times the first function. Okay, that was f. Let's keep on going. Let's keep on going. This is going pretty fast. Let's do letter G. Sure. Let's do letter G. I'm going to just grab G here. Okay, so what do we got here? I've got a couple choices on G. I could apply quotient rule, or maybe I want to simplify this algebraically. It would actually be simpler to simplify this algebraically. So if I look at this, the first thing that jumps out of me is maybe rewriting this like 2x cubed over x squared minus 1 over x squared, which, rewriting that becomes 2 minus x to the negative 2, right? So again, could I have done quotient rule? Absolutely. But is this easier? Yeah. So let's keep on going. So f prime of x equals, the derivative of 2 is 0 minus, so it's going to be negative 2x to the negative 3, which obviously simplifies to just 2x to the negative 3. Okay, let's see. Where are we at here? Where are we at? We did G. How about H? H looks like a good one. I think I'm going to do H, and we'll make that the last one for this video. So let's see. So for H, we're going to take the derivative. Actually, I'm going to do a rewrite on it. I'm going to rewrite this as f of x equals 4 minus 3x squared to the negative 1. And the reason is now that we have chain rule, right? That's a nice easy one to do using chain rule. So I get f prime of x equals, so that's negative 1 times 4 minus 3x squared raised to the negative 2. Then take the derivative of the inner function. So the derivative of 4 is 0 minus 6x, and we're good to go. Okay, so that's where we're going to stop for today.